Exercise 5 using Autodesk Inventor 2014. In this exercise, we're going to examine how to create assemblies using the bottom-up method. The bottom-up method is essentially taking parts that are already created and just putting them together inside Inventor using constraints, or relationships as they call it. So as you can see here, here's the goal, is to create this model. What you're going to be able to do when we're completed, hopefully, is you should be able to grab this handle with the left mouse button, drag it, and actually turn it around and see this dynamic assembly motion taking place, almost simulating how it would react in real life to some extent. Doesn't include kinematics necessarily or anything like that. There are some functions in there, and there is a kinematics and dynamics package that you can get for Inventor, but this is just the basics. This is just dynamic assembly motion. Okay, so let's begin. First thing you want to do is in your browser, just go to Vertanux, VERTANUX1.com. And now from here, you'll see this is the web page. And the reason I'm bringing you over here is the instructional manual is in there. If you wanted to grab that, you could open it up. So for example, just click on Autodesk Inventor. And it takes a moment, and it should open it up for you. It actually is using Google's Google Drive. And so if you want, you can set up your own account for that and copy it over. It's just a PDF file. It takes a little bit to load it up. Depends on how fast your internet speeds are. And there's the manual. So we could go here to exercise 5, which is further down. Anyway, you could also go to the part files. If you want to see the part files. And over here, exercise 5 under the Inventor area there. And notice lab 5B, that's the lab that comes after this. You're welcome to give that a shot too. We'll go to exercise 5 parts. Just click on it, and it should take you to a link, again using the Google Drive system. And once this comes up, you'll see all the parts. Now what I would recommend doing here, just so you can just drop these onto your drive. You can go to File, Download, and you'll see it will come, depend upon your browser, whichever one you're using. This is Google Chrome. Down at the bottom left, you'll see it's starting to download them, things like that. Well, once it downloads, it usually doesn't take too long. I have very slow internet connection here, so it's taking maybe a minute or so. But anyhow, once it's down there, it's a zip file. You can just click on it and open those parts up. So give it another second here. Anyway, what I'm going to do is I'm just going to go ahead and once you have them unzipped, you can unzip them into any folder you want to work with them on. Okay. Anyhow, so I'm going to go ahead. I have them already created. I'm going to go to iPro, New, and select Assembly. And from here, up in the upper left corner, go to Place, and find that exercise 5 folder that you should have downloaded with all those parts. They're probably in your download directory. They still might be zipped, so what you might do is find that folder, the exercise 5 folder, right click on it, and uncompress them or open them up or copy and paste them somewhere where you know where they're at. Okay, I'm going to start off though here with the sheet metal bracket. Find the sheet metal bracket on the list and hit open. And here you can see it's just kind of floating there. You could just click to drop it in. And then hit escape. So you only make one copy. If you keep clicking, it's going to add additional copies. Now the thing is right now it's moving. If I grab this, it actually can relocate itself. So what you might want to do is lock that down. You could right click on sheet metal bracket here and find grounded. This you'll see a little thumbtack, and therefore it won't allow it to move any longer. With the first part, it's a good idea to do that sometimes, just so it doesn't move around if we're trying to simulate dynamic assembly motion especially. Okay, So now what we're going to do is we're going to go to place, and I want you to find the next part, which is called the yoke male. Hit open, and just click and drop that away from the other part here and hit escape. Now what we're going to do is I tried to color code this a little bit so you can see that the surfaces that need to contact are similar in color generally. Like here's like this almost like a salmon or a pink color on both of these. So those are our first constraint that we're going to add. And to add constraint, you just click on constraint up here. And you could just go with typical mate or select individual options that are there. We're going to go with just the standard mate. And what you could do is you could click on the surface of this post. We want that to intersect into the center here. You could also click on the center axis too. It doesn't really matter. And you'll see it will pop in place. If you have your volume on, don't be scared. You'll hear a little pop. Just does that. Okay. Now at this point, hit apply. Now you might also not see all this stuff at the bottom like I had, but we are going to use that, so it's not a bad idea at one point in time to bring that down. So this little button here does that. Right now we don't really need it. Let's just try and optimize a screen space. Okay, I'm going to click and drag this down. And what I want to do is, actually I'm going to hit cancel, because by selecting that, it actually formatted my selection. Go ahead and just cancel out of that. As long as you hit apply, it should be good. Okay, now you could grab this, and you'll see you could drag it up and down, left and right, just by moving your pointer and holding the left mouse button down on your mouse. And essentially what you're doing is removing the degrees of freedom that you have here. But it's still floating a little bit more than we'd like. Now to stop moving it, just move your pointer, click somewhere out in the open screen to deselect it. Let's go back to constraint. Just leave it at the default again. And this time we want this surface here. Click on that. And then if you hold shift and your middle mouse button or the scroll, remember if you hold it down, drag it, you can rotate this a little bit so you can select this underside face here. Click on that. And it should snap coincident. Go ahead and hit apply. You can rotate this around. I'm going to hit cancel after I hit apply. And let's see what we've just done here. So we could see we have the part in place. If we grab it, we could rotate it, and it no longer moves up and down. So again, we remove some of the degrees of freedom that we had there. Let's bring another part in. Go back to place, and this time I want you to find the spider hinge. Hit open, and just click to drop it somewhere, and then hit escape once you got one on the screen. You can see the blue color code here. These blue surfaces are going to need to contact. Avoid the red ones. Don't worry about the holes right now. We're going to go to constraint, and actually we will work on the holes. The holes that have the blue flat face in front of them, move into those holes and you'll see the center axis appear. Click on that center axis, and now move over here to the side of that blue hole until the center axis appears. Go ahead and select it, and it should align. Okay, now hit apply, and now what we need to do is add another constraint. Like you could add this constraint here. If you select this face, be careful not to select this one on the other side. Instead, hold shift and the middle mouse button to rotate and select the face that it's closest to, which is on this back side, and hit apply. Right? You can hit cancel. Alright, let's bring in another component. Go to place, and this time we're going to bring in the yoke female. Hit open, and just drop that right about there. And then hit escape after you drop one in. Again, use the constraint tool. Get to the red surface on the hole there, and when you see the center line, click to the axis there. And this time actually it's the red face, the red flat face, but the inside pinhole is blue. So just select that face, that's okay. Alright, hit apply. And now this face here, this red face on the inside of the leg of the yoke, rotate that around to make sure you get to the red face here that it's closest to. Click on that. Hit apply. Right. So now we have those added. Now I'm going to hit cancel after I hit apply here, and you'll see it just kind of floats around. It's not fully constrained yet here. But what we do want is we want to get this green surface at the bottom there matched up with this light green surface here. So let's go to constraint. Now this is where you need to hit this little double arrow here and use offset as resting position. Because now what we're going to do is I want you to rotate and select that bottom green, light green surface there. Rotate it and select this angled plate with the green face. And it should align. If it fails to align, you might not have turned on the limits option under use offset at resting position. The reason why that occurred is there is actually a little distance gap. Normally when we use this tool, the mate, it wants coincident, which is face-to-face contact. It actually wants to touch. But that's why you might get an error, because this physically can't touch because it's constrained up above here. It will not try and pull the parts apart to make that mate. So just be aware of that. We're pretty much done with that, so you can bring it up. Hit apply and cancel. Okay, let's give this a shot. Now it doesn't have the pins in yet. Remember, you could click on this little, if you rotate this around, click on this upper corner here, it will bring you to an isometric of that view. Now you could grab the top part here, click, hold down, and drag in small little elliptical movements. And you should be able to witness the dynamic assembly motion taking place there. Okay. Just release it and click somewhere off onto the gray part of your screen. Now we're going to drop in the little pins. So go back to place and find the blue pin. You're going to need 2 of these. So hit open, click on this side over here on the left, and then drop one in the back here somewhere on the right. And then hit escape. We'll first attach this one. So go to constraint, glide up to the cylindrical face. When you see the axis in the center, click on it. Do the same over here on the blue hole. Get to the axis center, click. Hit apply. And now for the next mate, you're going to want to select tangent. Click on the tangent button up here. Select the end face. That's the flat face of the blue pin that you've just put in there. And then select this face here, the cylinder of the yoke. Now, it might appear on the outside back. That's an easy fix. Just click on inside, and it should flip it around. This solution option flips it align to anti-line, or inside or outside. Okay. Hit apply. Let's do the same on this one now. So let's go back to mate. Select the cylindrical face so you get the axis in the center. Click on that. Now you're going to have to shift and rotate to get this axis here on that blue side. Click on it. Hit apply. Rotate this around the back so we can see it. And now we could go ahead and make sure you set it to tangent. Select the end face of the pin to the cylindrical face of the yoke. And if it goes in correctly, you're in good shape. If it's on the outside, remember you can always flip these. Hit OK. Alright, now we need to let's go ahead and click on that corner there. Or you could go to home, it flips it around the other side. Okay, now we're going to drop in the red pin. So let's go to place, and let's find the red pin. Just need one of those. Click to drop it right there, hit escape. You don't need more than one copy. Zoom up if you need to with the scroll on your mouse. Go to constraint, and it's pretty much the same thing. Select the length of the pin, cylindrical face, so you get the axis. Click on it. Select the red hole so you get the axis. Click on it. Hit apply. Don't forget to turn on tangent for the next one. Select this end face to this gray face here of the yoke female. Again, it flipped it on the wrong side, so just make sure you click on inside. Hit OK. Alright, if you want to try this, drag it. As long as the pins aren't moving or relocating outside of the envelope, you're in good shape. Okay, now there are a couple little set screws that we need to add down underneath here. So let's go to place. This is just good practice. You'll find it's just called fastener. Click on the fastener, hit open, and drop You could drop 4 in if you want. I'm just going to put 1 in so I don't make the video too long here, and hit escape. But you could click 4 times, drop a bunch in if you want. And let's go now to constrain. We'll go with the mate, select the length so you get that center axis. Select one of the holes, apply. And this one you could keep it at mate. You don't need a tangent because it's not a radius surface. So you could just select this end face here to this face here. Okay, now it flipped it the wrong way. If you remember, under solution here we have the option of flush or inside. So flip that around. Hit OK. If you're not seeing that, that just means that you might have selected the wrong end face. I would just cancel, rotate the part around so you could see it better. So the set screw actually, the hex is out, the open there. But you could repeat that 4 times for some extra practice. There, as you can see, there's 4 holes total. Moving on, let's go back to this upper corner here. Now we're going to introduce a sub-assembly. It's no different than a part file. And you'll see here the handle is a sub-assembly. It has a blue and yellow blocks indicating more than one part versus a standard part file. It's just a yellow box. So make sure you select the handle and hit open. Now just one copy at the top here. Just let it float and hit escape. Now let's take a look at the feature tree. All the parts are listed, and the handle here, if you hit the little plus symbol, you'll see it has a little handle and a handle top. So there's actually 2 additional parts inside there with their own relationships. Let's go ahead and add those constraints. Click on constraint, select the cylinder on the outside, and select that axis, and then select this axis right here. Hit apply. Now you're probably better off just hitting cancel at this point after you apply it. Drag it up, and what we need to do here is we need to match up this face here, that little flat, with the flat that's on the inside of this. You can shift, drag this around to see. There's the flat there. So let's go to constraint again, and select. Make sure you select the flat. Be careful, there's a radius in there. You don't want that. You want the flat. And then find the one that's on over here too. Be careful that radius. You don't want that. And it should align. Hit apply. Remember, you could always flip it if you need to. Okay, now finally, this next one is going to be an offset. And we could plug in the offset in advance, I think. Here. It's just going to be an offset of 0.01. And rotate this around. Select that green face underneath there. And then we want it to be offset off the top, so it's not actually contacting that top surface of the surface. And you should be able to see there's a little gap, and that's that 0.01 gap that we added. Hit OK. And that's how you add offsets. If you go to home, you'll see it will show the back side. That's fine too. Or else you could rotate this around, or just rotate it to get it kind of like in the front there so you can see it better. And then there's this upper corner here, which will give you isometric in that front there. Okay, now the ultimate test. Let's see if it works. Just grab that little handle and rotate it. Hold the left mouse button down, and if it all works, you've done a nice job. And you are done. Just save this as E5 for exercise 5. Be aware with assemblies that you want a good practice is to try and keep the parts together if you're doing this as an exercise for a class. Keep them in the same folder. Otherwise, if you copy and paste things through Windows, it might have a hard time finding and relocating where those parts are. That's why I suggest keeping everything in the same folder. That exercise 5 folder works really well. Otherwise, in real life, when you're working in a company, a lot of times you have different servers, different drives. You'll find parts everywhere. Just be careful. Make sure that the parts stay in the same spot. Don't try and move them too much, or else you might lose some of those. You'll have to go search it, which isn't the end of the world, but it can take a lot of time. And this concludes exercise 5. Now go ahead and try exercise 5B, which if you click on the part files, you'll find that I should say lab 5B. Click on that, and again, it's just a zip file with a bunch of parts in there. It's an MP, actually a Bluetooth headset component scaled up, and just try putting that together on your own.